And we're gonna see what the agenda of today is. So today there are a few questions we're gonna answer. What is machine learning? What is not machine learning? Who are the people building machine learning? We're gonna demonstrate some code so you can understand how we do machine learning works, and what we didn't cover. Cool. So what is machine learning? So the general definition here, it's a field of study that gives computers the ability to learn without being explicitly programmed, okay? Regularly, computers do exactly what we tell them to do. In machine learning, the computer or the program's model can have the ability to learn sort of by itself. It has an algorithm that tries to minimize a loss function, and that way, it just looks through some data and tries to best fit it in the decrease of regressions or by reducing its loss function. The loss functions are measures of how far an estimated value is from its true value. With some regular programming, you just have an input and an output, and that's it. It does exactly what you tell it to do, but with machine learning, the program will do more than what you explicitly tell it to do. It looks through data and tries to get an algorithm to minimize the loss function. So once your model is ready, you train it. And you can retrain with new data and test it with unseen data that it didn't learn from. So today, machine learning models are super efficient and easily optimizable. There are multiple examples and we're going to see some use cases today. So let's go through some good vocabulary to have. Where is machine learning in all of this? Machine learning is just a subset of AI, so artificial intelligence. It is meant to learn on its own and receive new information to create new predictions. Meanwhile, deep learning is its subset as well, where it does the same thing, but in a more complex way by mimicking the human brain and creating artificial neurons and synapses. A neuron will receive then an input signal, and then it uses this information to decide whether to output its own signal to the network. So this is a sentence that I think creates the most sense about what machine learning does. Programming methods that use experience to recognize complex patterns and create formula for new predictions. Only when we talk about machine learning, we don't call it experience, we call it data. So we are talking about programming methods that use data to recognize complex patterns, okay? And when we say we create formulas, we want to say we create models for new predictions. So this is just like a little bit of vocabulary that we need to be acquainted with so we can dig deeper into machine learning. Sorry about that, models. Okay, so guys, today we're going to be a little more interactive if you would like to. So looking at this image, when you look at it, what do you think that question mark, what kind of color that would be? You can send your responses through chat, and I'm gonna open them here so we can look at that. Yellow, orange, exactly, very good. Yeah, everyone got it, very good. So naturally, it would be a yellow dot. So congrats, you are as smart as a machine learning algorithm. So how did you do it? You look at the dots, right? You recognize that there's a pattern. So you see 2 reds, 1 yellow, 2 reds, 1 yellow, 2 reds, 1 yellow. And of course, by habit, there's a pattern here. You would say the next one will be a yellow. And the dots here basically are representative of what the data means when you receive a data. And your brain is creating what we call a model that recognized the pattern and predicted an output. So how does it work? How does computer programming and machine learning work? So let's take a look into this example. Let's take our age versus height ratio, and we're going to input the age as our main feature, and the output will be what we're trying to observe. What we mean here is that input is a feature that we'll be trained upon, and the output is the target that we're trying to predict. Okay. So the question here is, how tall was I at 13? So what do? We created this chart. It has a y-axis as height, and it has a x-axis as age, right? With these, we plotted the numbers that we've just seen before. So these numbers, and we created this chart. The next phase is to actually try and extrapolate from new observations, what kind of, like when I'm 13, what is my height? So what happens when we have, we draw a line, we drew a line, as you can see, the red line right there. And it was close enough to almost all of the points that we can say that by 14 over here, okay, by 14, I will be 147, say, 147 centimeters high. It's pretty simple, right? But if this is kind of a kind of data that we have, of course, we don't even need machine learning. A human brain can do it. It's very simplistic, small, easily controllable. However, what happens when we have around 150 different features and say 1 million observations, and we have 2 million different people that we have information about? You can't really plot it anymore, and you can't visualize the data, and it becomes very complex to be done by hand or by person. So this is where we rely on machine learning to take over. This is what most apps are dealing with already every day, with millions of users and tons of information they are gathering from their users, okay? It would be impossible for them to handle it by hand, and this is why one more time we use machine learning, okay? So machine learning is already all around us. So let's see some use cases of it being used. The first one will be computer vision. One more time, it's basically classifying and detecting visual data. Let me ask you what kind of computer vision you have seen or heard about before. Again, you can answer me in the chat. I'm going to be opening it now. If you have an idea, if you don't, that's okay. Face detectors, very good. Face ID, Tesla, exactly. So many, exactly. Very good. So we're going to continue. So for this one, for this specific picture, we're going to be concentrating on car and autonomous cars. So for a car to be autonomous, the first thing it has to be able to do is see. It has to see where it's going to detect objects on its way. What you do is feed it enough information, so enough like street images that are hectic like these with a lot of information. So for it, and tell it what are the obstacles that it has to recognize. On this picture, the boxes, as you can see, you have purple boxes, you have the blue ones, the yellows, and the green. Each one is actually detecting something specific. So the blues are detecting the traffic lights, the purples are person, the yellows are cars, the greens are trucks, and you even have a handbag on the side, you know? So this is what we do. We give it so many like millions of information of pictures for it to learn, and then recognize it through driving that these are things that I'm not supposed to go towards. For a machine that has seen so many images till today, like we're still not at the perfect autonomous car, but we're going there. So already us as humans, we are able to detect this intuitively because we drive every day and we see these things every day, and we understand that we have to stop every red light and move towards a green light. And the thing is, we've done this our entire life, and our brain are much like more smart than a machine learning, and so that's why a machine learning model needs so much more information than you actually do. Okay. The next example, another example would be recommendation engines. So I'm sure everyone watches Netflix and binge watches this. And the way it works for Netflix, when, for example, say you watched Rick and Morty and then you watch Family Guy, it goes and sees someone else who did the same thing, Rick and Morty and Family Guy, and then what did they watch next? And because it's very similar, they try to recommend what that person watched to you. And of course, there are so many ways that they do this, but this is one of the examples. Another example would be Amazon. If you are using Amazon constantly, if you just save a product, or say if you buy a product or go see a product, all of this information is being grabbed and fetched from you. And once that happens, it is sent to their recommendation engine, and it's constantly giving you back an output of what kind of predictions what kind of products you would like. Sorry guys, someone has their audio on. Do you mind? Thank you. Okay, so these are all considered machine learning models. Next would be natural language processing, or NLP. NLP, or there are a lot of tools around us, such as, say, I don't know if you are acquainted with Grammarly for spelling mistakes, for spelling checks, and of course, chatbots. Chatbots are things that pop up now all the time in every website almost, and they ask you questions such as, hey, how can I help you? These are actually very complex models that were implemented by these companies to make it more efficient for us users and to make things faster. The next one would be time series. Time series, this is more of can past change predict future change. This is looking at, say, any historic data, and let's predict, for example, let's predict the weather tomorrow. We're going to look at weather patterns in the past, and we're going to predict it in the future. Or say, I want to predict the Apple stock tomorrow. For tomorrow, we're going to look at the Apple stock patterns of the past and give it an assumption. Okay. So that's pretty much what time series are. They're complex and much more difficult to handle. Then we have anomaly detection. That's predicting patterns in reverse. And what we mean by that, since machine learning is all about looking at the past and predicting patterns, it's also very good at doing the opposite of that. So finding many things that aren't within a pattern, predicting anomalies. If there was, say, a breach somewhere or a fraud, that's where cybersecurity comes into hand, and that's where like these kind of anomaly detection comes into hand. Since it's very good at predicting patterns, it's also very good at predicting something that's outside of the pattern, and it detects it as an anomaly. So yeah, good. So those are all some examples of things that are already around us. Now let's see what are some of the cases where it kind of becomes just a hype. And unfortunately, today a lot of companies are calling themselves AI companies or deep learning solutions. And many cases are very true, but there are also a lot of cases where it isn't. So let's see what is not and machine learning. The first thing to think about are questions of analytics versus questions of machine learning. What we mean by that are the questions that just need you to look at the data you have and do an analysis over it, versus questions that might need machine learning, where there is a lot of unknowns, where you don't know which data to use, or the data doesn't exist yet, or there's an output that needs to be created. Okay, so the first question, the first example would be a prediction there. So the first one needs, I want to predict salaries of potential hires versus do women and men earn the same in our company. So now, if, say, we have a data set of a company and we are able to access their salaries and their age and gender and all the right information, what we can do for the first one, we want to use machine learning, because there's a prediction that needs to be happening. You want to predict the salary of potential hires, of new upcoming hires. But the second one, do women and men earn the same in our company? We already have past data, and that past data can be treated by someone and just like shared into a visual way and done some analysis for you to get the right answer. The next one would be why this marketing channel brings the most clicks versus which marketing channel brings the most clicks. And this is very tricky, right? It's the same question with just like small differences. The thing here is that why this marketing channel brings the most clicks it's something that is unknown, right? It's an unknown data that we are trying to solve, versus which data that we already have, like we're just trying to find it within the data that exists, and not why, which is something that it's not there yet. And the last one would be, how are our sales looking if we open in this new country versus how are our sales looking for next quarter? Okay, so this one's a little bit more tricky, right? The second question can be interpreted in both machine learning and not machine learning, but let's consider it an extrapolation question, similar to what we've done earlier, okay? So, however, we might not know about a new country. A new country is all unknown data that we need to go and assess and get the right variables. We need to understand like what are the habits of consumers in this country. We are like so many more variables are needed to get to this answer, versus how are our sales looking at the next quarter, where we can do somehow of a hypothetical analysis. Okay. Another case is when you are missing the ground truth. So there are cases where the machine learning model barely finds a pattern, okay? Let's say we're trying to create an AI that will recognize the perfect candidate for a job, the perfect accountant or the perfect cashier or the perfect, I don't know, say assistant or whatnot. The problem here, all of these questions are dependent on a lot of factors and a lot of variables. And those factors are changeable per country, per company, per personality, per owner, per CEO. Like so many other factors are being needs to be accounted for. So we don't really have the ground truth. There isn't like one truth. It's not black or white. It's really a little more gray area. And that's why if it doesn't recognize that, it will never recognize what a perfect candidate is, because we're missing the pattern here. There's no such thing as a pattern. We can get close and closer towards like one specific company where they know exactly what they need and it's a little more precise. And even then it becomes a little more complex to create. So to give you another example, we are able to create an AI to be the best player at chess, right? But we are incapable of creating an AI that will be able to change the best pipe, because changing pipes has many unknowns, right? So let's say, I don't know, they're using a specific brand. We don't know what the problem is, what kind of plumbery they have. If it's dark, if it's not, do they have light? Do they not? Like there are so many other factors that come into hand. So you can never actually create a machine learning model that will do that for you. I mean, a robot that will do that for yourself. Okay. Another example is when things are changing all the time. So the machine doesn't really understand what to do. Okay. Let's take a drug analysis as an example. If we look at it from day 1 to day 5, we start at 10 milligrams, we go to 15 milligrams, 20, 25, 30, and go on. So what do you think by day 6 we would have? By the way, there are no wrong, no right answers. Just give me, if you want to participate, you can go for it. So most people are saying 35, 35, 35, which would make sense, right? But because we are dealing with drugs, we are dealing with a medication, that's actually very volatile. Maybe they have to stop at day 5 because that's what it was prescribed to them. Maybe they have actually to go backwards. They have to go back to 25 and go slowly and really and get rid of that medication slowly. So actually now we have an example that makes you know, we don't actually know if we should increase. We don't know if you can remove it. We don't know if we have to imagine you give it 35 and then that person gets into an overdose, say. So we start thinking about like, how can we make this easier for us to understand? Here we go. I also like this example, which is very funny, about extrapolating. So let me read through it first. As you can see, by late next month, you'll have a dozen husbands, because yesterday you had 0 husbands and today you have 1. So if we draw the line, then you'll have a dozen husbands. The thing is here, what it means is that if you just do a linear regression towards just a simple like mathematical problem, of course you'll get dozens of husbands, but that doesn't actually work all the time. So that's what I want you to keep in mind, is that not all problems have a machine learning solution. Some problems are supposed to be just an analysis. Okay, so let's see what happened last year. A lot of companies, to manage their inventories and manage their supply chain, they actually struggled for a while because of the pandemic, right? The problem was when they didn't know anymore, like the habit that they used to have and the models that they used to have weren't perfect anymore, because the pandemic changed all the orders. They changed the consumer behavior. They changed are we in quarantine? Are we not? Are we allowed to go out? Are we not? Some people lost their jobs. So all these variables have become so important in our life, in our lifetime, that all the models that these big companies had just didn't work anymore. Okay. Because they basically didn't have the right information anymore to output the right prediction. Okay. So Robin Hanson is a great economist. he said most firms that think they want advanced AI and machine learning really just need a linear regression on cleaned up data. The thing is, most companies don't invest time into cleaning their data. And that's why data scientists and data analysts find themselves most of the time doing the pre-processing and just cleaning and cleaning and cleaning and really making it the best data to input into a model. And if they just gave us like a good set of data, it's much easier to get to the next page and like optimize your models and make it the best model that you can possibly have. And this is what we call garbage. Garbage in equals to garbage out. If you are feeding your model garbage data, then your model is going to output garbage predictions, because no matter what, whatever information you give your model, the model is going to work. It is meant to work. It is meant to give you an output, but it's not meant to tell you, hey, your data is crap. So good. So now I kind of explained what is machine learning. I tried to explain to you what is not machine learning. And now we're going to see who are the people building machine learning. So we have three circles. We have math and stats in one, insight and communication in the second, and code and engineering in the third. To be a data scientist, you kind of have to have all three. You need to understand the mathematics that happen in the background. You need to have a lot of insights. You need to understand how to read data, how to just make sense of your data before you even enter a model, how to clean it up, how to pre-process it. And then, of course, you have to know how to code it. Engineering is a little less, but it's always helpful to know how to engineer it. So today we have also what we call data engineer. A data engineer is the person who works with the code and the infrastructure behind to make sure that the data analysts and scientists have all the tools they need to do their work. A data analyst who is usually analyzing the trends in existing data and communicating those trends with the non-data people. So creating, for example, dashboards and visualizations, and basically what we've been doing yesterday if you were here. So we have a question mark on the right. And that question mark is it's there because there is no like set in stone kind of position. But what I like to put here is the citizen data scientist, someone who has a lot of good domain knowledge and is able to communicate that domain knowledge. And then someone who picked up like enough code and engineering, like pandas and all that, to be part of this data world. The sector by now has so many more sectors. You can be a business analyst, you can be a data product manager, a database admin, and like this is where the data field just gets bigger and bigger, because the world is becoming more data, and data is gold. However, we believe that every department needs some automation because data is everywhere, right? So say digital marketing, or strategy and planning, all of these sectors have digital marketing. You're dealing with users, you're dealing with their trends, you're dealing with what kind of information you need to give them. So all of this stuff is not automated 100% today. And if you just like refocus on what you can do with it, it will always give you you will develop your company to the best place. You will grow, you will reach other people. It's always a good idea to go towards data. So where data science can be of use, we had a few students in our school, the Wagon. One of them was a data journalist. It was in data journalism. She started a journalism chapter in Shanghai, and all she was doing is talking about data and the newest trends, newest models, and whatnot. Then you have another cool one was a film coloring person. They are using machine learning to decide what should be the color of a scene of a movie. They use it to move the camera instead of like having a person to do that. So they're really being smart about how to maximize efficiency within their work in their work environments. Then there was a really cool one too. It's called it was a bicycle building. So they use machine learning to understand what makes a high performance bicycle by watching the changes in weight and the angles, and I don't know, like a thicker wheel, a smaller wheel, and all these little changes are being like constantly put into a database and constantly like reiterated and changed by the minute. So if we always if we did the same thing as these people and put all of this into finance, marketing strategy, everything could be automated and everything could be very like powerful. All right, so we are ready to code our first model. Oh yeah, so I'm gonna show you what we're doing today. So this is what we call the Learn platform that I've showed it yesterday if you were here, but if you're not, we're gonna be sending out a link and you can be onboarded and you have access to all of this. And part of today's challenge is going to be predicting salaries, and you can have it right there. So you can just go to this challenge number 1 and have access to it. So for me, I already have it in my terminal. We've seen what a terminal does. So just to have access to your computer without necessarily like turn around thing, I can open my Jupyter notebook. Sorry, guys, someone has their mic on. Cool. So now I open my Jupyter notebook. We'll put it right here. I have already my raw data and then my clean data that we've processed ahead of time. So the goal for today is to predict with this clean data that was pre-processed by us. The data is of companies and their employees. The model that we will be coding is to predict what salary our new hire should have. We have, so let me open it first, linear prediction. Cool. For those who weren't here yesterday, I'm gonna actually go through my yesterday's data analytics. So we can also have a small recap of all the basics that we need. Cool. So this is Jupyter Notebook. It's a text editor that we use, data scientists use all over the world. It's very easy to manipulate. Every cell is a code cell. You can check it over here. And every cell is changeable. You can just press in the drop down, it can become a markdown, just like the Let's Start data types. If you want to have titles, the heading is the same thing, or a raw NB converter. So it acts when you give it something, it will output something all the time. For example, this one, 2 + 3 was outputting for me a 5. It does simple algebra problems. What you need to remember are the data types that are very important, because some the models that really need integers or floats, and they can't necessarily have text. So the first one are the numerics. We have integers and floats. Integers are just numbers, any number, and floats are any decimal number. And then in the texts, we have strings. Any text has to be between quotation marks, and that's how it is going to be recognized as a text. Then we have Booleans. Booleans is a true value or false value. It will, we can do algebra with it. So when you say true and false is equal to false, and true is true, false or false is false. And these come in hand later, because we are able to pick certain, like say if you have a huge database of prices that are of every like ranges, and you want only prices that are lower than 500, you can do that through Boolean algebra. Then we have variables. Variables are placeholders. We can give them information and they store it in there for a while, forever, if you want to say. Every Jupyter notebook reads itself from up. I mean, every editor in general will read itself from up to down, and then from right to left. So what we mean here is that it's going to read up, down, down, and then it's going to go here. It's going to read Casablanca, because that's where I'm from. And it's going to read equal, which is not an algebra sign. It's really just like assigning something to city. So now city, Casablanca lives inside of city, and city is Casablanca. Then we looked into some functions. The functions are built-in functions. You have built-in functions for Python. who facilitate like changing the behavior of certain things. Like say, for example, this one, my name is Kenza, it's a string, and I want to capitalize my first letter. So I will, just call the function name on top of my object. By the way, if you have all of these functions inside of the Python documentation, and if you want to make the change to the name, you actually need to set it back to a variable. This can be named anything, but I like to keep it the same. Another cool function that I would like to show you would be upper, but I don't think it's gonna, yeah. Cool. Is upper, we'll just change all the letters into capitalized letter. Then we looked into Pandas. Pandas is a very powerful tool that was also built for Python. It is used for data science all the time. It like facilitates us to read the data sets. It can read any type of data set, like let's say PDFs. I mean, JSON, HTML, CSVs. You have all of that within your documentation. And you create them. You can, once you read your CSV, so that's the name of my data set that lives within the same path. I set it equal, so I signed it to listings df, which is a data frame. So this is what a data frame would look like. It has IDs, it has all the names of the columns, it has all the information per person or per inquiry. And yeah, you can just check before you start doing any code. You have to start doing some checking of like what is the information. So you check the shape, the columns, the type. You check how you can see with this built-in function. You can see only 10. Say if I want to see only 10 entries and whatnot. Then we did some cleaning of the data. You do so by checking how many nulls, how many not a number, so nans, not a numeric that exists within your data set. As you can see here, we had 10,000 in the last review and we have 10,000 in the review per month. The first part you can just drop, for example, let's say the name, because we don't really need it. We can drop the last review because we want all the reviews. So that's what we've done next. We dropped the host name in the last review, and then we checked again if it's how that changed. As you can see, now they don't exist in our data frame. And then what we did, because we really want to keep our reviews per month, we have filled the nans with zeros, just as a like holder, so we can have a cleaner version to play around with. And voila. Then we have two types of data frames. We can have the data frame, and then we have series. So series, you grab them with just a one bracket, and it will give you back just two columns, one of the IDs and one of the information that's within the column. And then if you want a data frame, you give it two brackets, and you can give it as many columns, and it's just gonna give you back a cleaner table. It also tells you how many entries exist within your data frame. You can also select by taking on the indexes. So here I'm saying I want within your data frame, I want to select index 0 all the way to index 5. And that's exactly what it's giving us. Then this is what we were talking about earlier. Sorry, I'm just gonna. Okay. We're going to, so this is what we call Boolean Algebra. So we are saying, hey, I want you to grab in your data frame the price column, and I want you to do less than 100, and all the prices that are less than 100, and it will give you back a series of all of your information. And when it's right, it's right. When it's wrong, it's wrong. That's it. So I think for now, we are good to, as a quick recap, and we can go to our main challenge for today. So today, this is what you're going to go through. You're going to make a prediction of the salaries. they're gonna start you off with some from quick mathematics, some Python basics, as you can see, and then at the end we're going to do some prediction. So here, the goal for today again is to predict the clean data. And what we can do, I can show you around a little bit, but not too much, so you can have as much fun as you can on your own. So here we are importing all the right libraries. So we are importing pandas, numpy, and seaborn. As we've seen, pandas and numpy are going to change the behavior. They're going to allow us to really play around with our data frame as much as we want. And seaborn is for data visualization. So we're going to enter shift this cell, and then we're going to load this one. And here is our data frame. It gives us a couple columns. We have the gender column. So when it says 0, I believe that's a man. And when it's a 1, it's a woman. That's our age. That's our department, the department code. And then we have the years of experience, the tenure of months. So how many months they have been here. And finally, the gross, which is the salary. Okay. So this is where they want you to kind of visualize and understand your data first. You're gonna need to check it out. I don't know, say we can do salaries, salaries dot shape, and we can know how many columns and rows we have. We can also do the D types to understand what are the types of each column. So here we are dealing with integers, objects, integers, float, integers. So we have one object, which is going to be the department, because those are strings, right? Okay, and the last one, if you want to like visualize your column names, you can just pass on the dot columns. There are so many other ways to visualize and understand your data. You can go through that on your own after. Okay, so another thing, before you start coding your model, you can do some visualization. To visualize this, I'm going to do a quick one just so you have an idea. So it's called you call on your SNS. So we imported the library, and you do a scatter. Let's say I'm going to do a scatter plot. You pass on your data. So data is equal to salaries, and then you're going to pass on your X value. Say here we want to see the years, I don't know, years of experience. So you're going to pass the name of the column, years experience. Okay, and then we're going to need a Y for your Y axis, so the information that will be passed on there. And let's say salary. So that's our output. Boom. Here we go. So here you can already have an idea how your salary versus the years of experience are correlated. You can see that it goes, the more experience you have, the more money you will possibly have within this company. We can also do something really cool that I like to try out. We call it hue. So if you add hue all the way here, yeah, hue will give us a color for, let's say, if we use gender. So gender, we have 0s and 1. I believe gender is written with a capital letter, but I'm not sure. So we're going to pass it. Yeah, it was. So here we can see the blues are the 0s, so the men, and the yellow, the oranges are the women's. And we can visualize there aren't so many women in this company. That's a bad thing. All right. So we're going to go back to the rest of the slides, and we're going to come back to actually doing our model in the next version. Okay, so we were sorry about this. We're gonna go back to where we were. We've seen who are the people, and we got to the demonstration. Before we do some machine learning, we have to do some analysis, as we've seen. By the way, all of the responses are within this slide, so I don't want you to directly go to your slides. I want you to really try to understand the challenge. And even in the Jupyter notebook, as you saw, there's always like a reveal answer. If you click on it, it will give you the answer. But the goal of today is to learn and to try to understand on our own. So we're just gonna skip all of this, and we are here. We're going to talk about linear regressions first, okay? Okay, so I'm sure everyone has seen this graph at some point. It's called a linear regression, and that's the equation we use, y equals to ax plus b. Oh, sorry, guys, someone raised their hand. Yes?
Mohammed, maybe you have something to say, I think.
Yes, are you able to hear me?
Yeah, I can hear you. Hi.
Hi, Kinza. Awesome presentation. I just wanted to request you to please click on the homepage of the Jupyter Notebook for machine learning.
The homepage for Jupyter Notebook?
Yes, the second tab. The second tab. Yeah. Awesome. Awesome. Thank you.
Okay. Cool.
Yep.
By the way, you get this Jupyter Notebook, this Jupyter dashboard. You're gonna have it on the slides. There's a thing that we use. It's called Binder. Once you click on it, it gives you all the.
Yep. Actually, I was looking for the Binder link so that I can open it in my own browser.
I believe it exists within these ones. Do you have access to Learn?
Nope. That's the main issue.
Okay. Charlotte?
I'm trying to find why we can continue to chat for you to have access to Learn.
Yep,
okay,
indeed.
perfect.
And thank you for that.
My pleasure, of course. All right, guys. Let's go back to our lecture. So linear regressions. Linear regression solves a lot of machine learning problems as long as we are doing it on good quality data. Okay, so we're back to this what Robin Hanson said. Most firms that think they want advanced AI and ML, but they all need a linear regression on cleaned up data. It was shown on this survey that the model that's mostly used are regression models, and this was done in 2018, 2019. So for this graph, we're gonna do a quick, we're gonna do a quick demo and to play around. So I, as a human, I'm gonna zoom in first for you. Here we go. I'm gonna be able to make a linear regression model and let's take hand size, right? We have hand size information versus the height. So what we want to do is we want to predict the height of a person through their hand sizes. And the cool thing about this, so now let's try to move this. You can move, it's very interactive, by the way, so you can play around with it as much as you can. These are the points. These are your information of the hand sizes versus the height. And this is the line that you try to really get as close as you possibly get to get to that right information, to the next information that you're looking for. Okay. As you can see, like if we really want it close, you can play around with it. So by now, what we can say with these numbers is that we are capable of predicting the height of someone by just doing a multiplication and in addition, through their y-intercept and their number of the slope. However, let's say we have another feature. We have, I don't know, there's shoe size. So we have two features that we take in consideration. Oh, by the way, this is before we go to there. This is a really cool demo. So what we're trying to do here, we're trying to get the boxes to be as possibly small as they can. And that's how machine learning actually works, okay? So let's say we're going to be able to play around. I think that's the maximum I can possibly do. So as a human, this is all I can possibly play around with until I find the right one. So let's say now we have two features. We have what we call the hand size now, and let's not think of this as a hand size either. We're gonna think of it as a shoe size. So now the thing is, we have too many informations that on our hands, and we need to be able to really, now it has become like a 3D, three-dimensional graph, and we need to make sure that these boxes become as small as we can possibly have. And that the red one is the linear line that makes the next predictions. So here, if we play around this, as you can see, that's pretty much it becomes harder and harder every time you add a feature and a feature. As a human, I am able to do 1, 2 features. Even this, if we play around with it for a couple minutes, it's one day or another you're going to be able to make it as small as you possibly can. But then when it becomes a little more complex, when you have 5 or 4, 5, 6 features, then it's a 4D, a 5D, a 6D, and all that. It's not even comprehensible in your head. And that's where machine learning becomes a very, very important part of our day-to-day. So the road to machine learning, before we get there, I'm going to go back to the Jupyter notebook. And this is going to be almost like our recap. So now we've done our little bit of visualization or whatnot. You have many questions that you are going to answer. And we're getting closer to our first model. So this is going to be a linear regression. The first part of any model, you need to be able to recognize what is your output and what is your input. What is your feature? What are your features? What is your target? So basically your X and Y's. To be able to give that information to your model, and it will train on it, and then it will give you back a prediction. So here, we know that we want the salary as our target. So we're gonna grab it. We're gonna grab our data frame salaries, and then we're gonna say, hey, I want you to grab only the column gross. And on our features, we're telling it, hey, I want to drop gross and department, because department, as you've seen earlier, department is, right here, it's text, it's characters, and the linear regression will never be happy with text. It needs only numbers. Okay, so we're going to drop those 2, and those are going to become our new features. Then the first part of the second part of linear regression, you need to be able to import the right library. So if you go here, which it's called Scikit Learn. Right. So this is the library that people use for machine learning in Python. Scikit Learn is available to everyone, so it's an open source, and you are able to. You can see here. You have classifications. You have so many regressions. You can do some clustering. It gives you different types of modeling selections. You can do some pre-processing for your features beforehand. So it really is such a smart tool for you to use. Oh, so here we want to go into regressions, and we want to be able to import the right model. Today we're going to be doing a linear regression. So from sklearn, which is Scikit, we are grabbing linear model, which is a folder, and then we are importing a file, and then we're importing linear regression. Okay. So once you do that, you're just going to enter Shift. The next part will be to initialize the model. So what we mean by initialize the model is really just to do almost like a placeholder, create an empty model that we will train afterwards, just to have it there. Mohammed, you raised your hand. Yeah?
No, I think it's still raised from the previous question. So.
Oh,
I'm really, really sorry. Sorry for the disturbance.
That's okay. Don't worry about it. Cool. So we created the model as a variable, and we're placing the linear regression, so the model inside of it. This is going to be an empty shell, almost like an empty shell that our model will be to prepare before our training. The next part is we need to fit our features and our targets. So what I mean by fitting It's a very simple function that you do. It's a dot fit. What I mean by that is that all the data that we want to feed it to this linear regression, to this model. So it starts learning on its own, on creating a pattern for it to give you back an output. Okay. Then we can see how good of a metric we have. We use model.score, as you can see here, and we pass on the arguments features and we pass on the argument target, which is what we have been working with earlier. So the score here, to score our model and to see the performance that it is, this is not an accuracy model. It's not like we're saying, hey, this is like so at 40% accurate or something like that. It's more like it's explaining that the data we have predicted is almost 44% of the change in salary. So what it's saying is that if we had more data, it would do a better job at predicting. Of course, like we were playing around with like 1,000 something rows. It's nothing. This is just to understand how models are working and to make it fast and quick, because if we had, say, millions of rows, we will just stay here for a couple hours. Okay, and the last part you would think is prediction. So here they're giving us a variable called hire. So this is representative of our new hire. We know that it's a female, so 1. We know her age she's 29. We know which department she's working on too, but if you would like to know, you just go back to the first, here we go. So, I mean, you can look into it after. Here, media. And then, so we know that she's in media. She has 5.2 years of experience and she's been working for 10 months. So how can we know, how do we do a prediction on this? We're going to call on model. So that's a model. We trained it, we scored it, and now we're ready to do a prediction. So model.predict, and you pass on your hire. Once you do that, oops, I wasn't like going through. All right. Always. Very good. So the prediction here with our model, they're saying that this person is going to get around 93,000. I believe this is an American company with, let's say, $93,000. So the thing is, we don't have a smart model. It's very small data, a lot of data leakage, and let's see. But we know for sure that this is going to be biased because earlier in the graph, we saw that there are so many more men versus women, and therefore, if we just change the gender for this hire, it will already be a higher salary. So that's the problem today, is that we can get a lot of biases. We need to constantly make sure that doesn't happen. And yeah, the next part, the problem that we data scientists have the most problem with is that we do not explain by now, what models, how are the models working? So models are so complex and so mathematically driven that it becomes hard to explain what they do. Luckily for us, today we're using a linear model, and it's just very much like a continuous line. So it becomes a little more forward to explain. But you have to find the right, intercept, the right slope to make it, the right intercept and the right slope to make it work. And what this means, if I don't know, let's try to see the coefficients. That will make things a little bit clearer. The coefficient, the coef. So these are almost like the coefficients that say the target changes with a change of 1 in each of the features, okay? So let's try to visualize it so you can have a better understanding of what this does. The first one is about gender. The second is age, department code, and whatnot, okay? So what this means is if gender is 1, so a woman, the salary is likely to go down by negative 24,000. And if age increases by 1, So the salary is most likely to increase by $9,500 almost dollars. And that's what this kind of, what the coefficient is trying to make us understand. And finally, we have the model.intercept, which is the intercept. And the intercept just means that if this person is at 0, so a baby, a newborn, they are making negative 188,000. But this is not so accurate due to the small set, but just to kind of basically understand essentially what machine learning is doing. Okay. So we're going to go back to our slides. So now this is the road to machine learning. What you never not do, you always have to go through these steps. The first one, select your features and your targets, your X and Y's. You will need to know what is it that you want to input and what is it that you want to output. Then you have to do your right importations. You have so many models. You have linear regressions, logistical regressions, you have KNNs, regressors and classifiers. You have so many different types of models that you need to go and look for, depending on what kind of data set you have and what is it that you're trying to find. What is your question? Then the third part is the training of the model. You train it with your information, with the data you have, and then you score it to see what kind of performance this model is doing. And finally, you predict. Cool. Again, you have all the answers of the problems here, but I would like you to kind of go through them alone before you go to the slides, okay? Yeah, sorry. Last part is explaining the model. As I said earlier, it's kind of hard looking at what influences the salary according to our model, but like it just, every time you try to use a model, try to understand where it's coming from. So it's easy, right? But no, but not really. So our model is pretty silly. Here, it's very silly. It sees age as directly correlated with salary. So if age was 1,000 years old by now, it will have like, I don't know, say 20 million. And that is not actually an accuracy, right? So another thing we are really cheating on, this is what we are cheating on. So we are training our model on the features and the targets, and then we are scoring it on the features and the targets, which makes no sense, right? Because say, for example, you are at university and your professor is very kind and he gives you all the questions that are going to be in the exam, and you study the exam, those questions, and then you come to the exam, and of course you're going to do well because you've seen those questions, you know the answers. So all you have to do is really remember it, right? So that's what we're doing. So the score is really not an accurate score. So the problem here is that we're scoring the model on the same data and that we used to train it on, and yet you are still failing. Remember, we had like what, 0.43, which is very small, and that's what we call a data leakage. Okay, so people were already able to see it. So that's a big cheat sheet. For our second challenge, we are going to get rid of that. And I'm going to try to teach you like the meaning of other important things. So we have a data set from a bank, and the goal here is to predict the customer's churn. The customer churn is really whether a customer is likely to stay or to stay within the bank or to drop this bank. Okay. So the difference between, now we're going to do a classification. So we've done a regression. Now we're doing a classification. And the difference from what we have seen earlier versus what we will be doing now is that we want our model to give us a prediction about what the salary is before and to give us a number. And a classification problem will give you a yes or no kind of response. It can be one or the other. Let's say, what is the temperature going to be tomorrow? And that the regression model will give me like a number, 84 degrees. And will it be cold or hot? It will be, oh yeah, cold or hot. It's not giving me anymore a numeric, it's giving me an assumption. So we are going to use another model type. This one is called K nearest neighbor. K here is just a number. So let's say we have two customers, right? And then we have class A and class B. Class A will say it's gonna be those who leave the bank, and class B, those who stay in the bank. Now the idea here is whenever we have a new customer, that customer will be added somehow here, right? Let's say the star is the new customer. It will be added into this chart. This model literally will check its neighbors. And that's why it's beautifully like said, it's just like the little neighbors around it. So it's going to check here it will check the 3 nearest neighbors if they left or stayed in the bank. And through that, it will give you an understanding of what kind of behavior this new customer will have. Okay, next, we're gonna do another demo. We're gonna try to visualize this. So let's say the orange people are gonna be the people who stay, and they're nice, and they're a little bit of everywhere. Okay, and the purple people are gonna be the ones that leave, and we don't know why. We're trying to understand why they're leaving. There we go. I think that's enough. Okay, and then over here, they give us the opportunity to choose like what number, how many neighbors that we want to use. And for now, we're just going to do 3, and we're going to try to train it. Cool. The way to read this is if the new customer, say, falls within the yellow brackets, the yellow lines, that customer will stay. But if the customer falls within the purple one, that one is most likely going to leave. And that's how we kind of understand our model. Next, we're gonna actually now, sorry, we're gonna go back to checking our challenge, the second one that you will be working on. So this is the optional challenge. It's about KNNs. So let's check it out. They also provide you from at the beginning, just a little bit of Python basics that you can go through, and then we can start applying our k-nearest neighbors. So the first part is importing. Always important. Import the necessary libraries you need to work with. Then we're going to read our CSV that's already been cleaned again. So this is our turn. This is a little more. We have many more columns. We have the credit score, we have the gender, the age, the tenure, the estimated salary, and the exited. Here we know that exited is, do they stay or do they leave? We want to know, I believe 0 is them staying and 1 is them leaving. Well, let me double check that. Yeah, all right, well, let's think about it like that for now. So that's going to be our target. We want to get a prediction if they're staying or leaving. So 0 and 1. The first part, you will need to also visualize it before you start playing around with it. I'm not going to do that, so you guys can play around with it. Then so we're going to start by importing the right library, the right model from our library, Scikit Learn. So it's from Scikit Learn, and this time it's different. It's called neighbors. And we will import k-neighbors classifier. So let's run this cell. Then we're going to do the same thing. We're going to initialize the model. To do so, you create a variable model and you pass the k-neighbors classifier. And you give it the n neighbors here. It represents the k that we've been seeing earlier. And let's say we're going to give it 3 for now. Okay. Then this is the time where we're going to create our inputs and outputs. So we have our x and our y. This is actually how we work with what we work with. We don't write normally features or targets. We really use x and y, and that's how we process the data. So our y is grabbing from the churn data frame, exited, the column exited, and then x is dropping exited from that data and grabbing everything else. Okay. Okay, so now we want to be able to do some fitting and then do some scoring. So let's say we are fitting our x and y, model that fit, and x and y. Very good. We get a response from Jupyter, and then we're going to do a model that score. Oh, sorry about that. Model that score, and we're also going to pass our x and y, which is not really good behavior because again we are saying basically, hey, I want you to give me a score of the things that you've already seen, and that's not important to us. So here, however, this challenge is already giving you a better score, right? We are at 80%, which is a huge score. And this one is actually because we're doing classification and no more regressions. This is not a loss function that you're getting. It's not a scoring a loss metric. It's an accuracy one. Okay. So basically, this model is saying that out of 100 predictions, 80 of them will be accurate. Okay. Let's go back to our slides. We have a leak. The score will be very high, of course, because one more time, we have the data leakage. We are training a model on the data and scoring it on the same data to fix that what we use on the same data, sorry. So to fix that, we have a thing that we use. It's called Holdouts Method. So the Holdout Method is very, very cool. So you have a whole data set for you. You have all the information here. What we do is that we try to separate it. We try to have two types of sets. We want the training set and we want the testing set. So the training set is what we're going to fit into our model, and that's what the model is going to see. But the test set, they're not going to see it, and that's what we're going to score it on to see if the prediction of those scores were as accurate as the ones that we had. All right. So to do so, I'm going to go back here. Everything is already done for you, so that's the beauty of data science. You are going to import the right method. It's called train test split. It's coming from Scikit Learn as well, and it's from model selection. So we're going to import that. And then you set 4 variables. We want our X train, we want our X test, we want our Y train and Y test. And then you make it equal to train test split, which is what we have just imported. And you pass on your variable X, you pass on your variable Y, so all of your input and your outputs, and you give it a test size. So most of the time you give it a test size of 0.3 when you have a very big data set. But because we have a tiny data set, we're just going to do 0.2. All right, cool. So now we are going to do what we've been doing earlier, and we're not going to actually, cheat. So model, we're gonna do a new model. Let's say k near neighbors classifier, and we're gonna do n neighbors equals 3. Okay, and we call this model no cheat. Okay. So model no cheat dot fit. So we're gonna fit our X train now and our Y train. So this is only using, again, the holdout method, the training set. Then when we want to score it, we're going to call on model no cheat, and we're gonna do pass on score, and then we're gonna pass the X test features and the Y test features. Cool. So now we can see that this is very much smaller because it's a little more accurate, like this is not what we've seen earlier. It's, of course, it's going to give you almost like, if you play around with it, like let's say over here, if I put n neighbors is equal to 1, I'm sure that our model is going to be ridiculously, yeah, exactly. It's going to be 100%, which is like what we all try to do, but that's not realistic, right? It doesn't make sense. If anything, it's overfitting. So that's the point of machine learning, is to constantly be in that balance where you're not underfitting and you're not overfitting. You don't want, for example, if you go back to this one, you don't want to have 1, because if you do, then it becomes so much smaller and it's too accurate. So of course, if I have it like right here, another one, it will be considered a yellow, an orange, but it's technically like purple. Sorry. Cool. So we've seen two types of models. We're gonna move on. Oh, it's your turn already, but give me 1 second. I want to give you a little bit of last things to do. We're going to do a prediction on our new model. Okay, so we have a new customer. It has a credit score of 608, a gender 1, so female. The age, we have the tenure and all the right necessary information that we are feeding to our model and that we want an output from. So to do so, it's as simple as model.predict, and you pass on your customer. At this time, we're using the no cheat because we don't want to cheat. Predict, and then we're passing the customer. Cool. So we can see here that it lives within the 0, and within the 0, that means, let's go back. A customer has exited or not exited. I honestly cannot find within this notebook which one is which. But let's say 0 is staying and 1 is leaving. So this one is staying, okay? Where is it? So this one will be staying. Let's say, let's play around with this. So if this is gender 0, it's still staying. If we have a credit score of 400, it's staying. If we have, say, tenure of 10, still staying. Interesting. So estimated salary, let's say we have 100. It will be staying. Okay, great. Another last function that I like to use as well. It's the predict proba, and that will give you the probability of both. Cool. It's a little too accurate for this one. Let's go back to how it was. Okay, so let's command.
So you're using the model and not the model.
Oh yeah, thank you. It's still not happy though. All right, model underscore node sheet should be fine. All right, second. Let's make it. X train, Y X test, good. Model node sheet, customer model node sheet predict 0 model node sheet. Here we go. Oh yeah, by the way, with Jupyter Notebook, sometimes it just stops working and it breaks. So when you have that problem, you go to kernel and you do a restart and run all. So it starts again fresh from the beginning. All right. So yeah, here we know that it is at 66% accurate that this person won't leave versus 33% that it will leave. All right. So that's pretty much it for today. So now you know what machine learning is. What is the concept? We've learned what the concept of machine learning is, the basics of Jupyter by now, how to use the Python libraries, import and visualize the CSV data set, how to build your own model. We have seen all of this, but we did not cover a few other things. So there are multiple model types. We have a decision tree based, we have the probabilistic ones, we have logistic ones. So it's a little bit, if you are interested, I would rather you go through this and check out like what kind of information you can grab from all of these model types. And yeah, I think for now we should be fine and we can open the floor for Q&A. Thank you so much, you guys. I hope this was informative. So Daniel has a question. Yes, Daniel?
Yes, thank you, Ms. Kanza. I just want to ask, remember at the start when you said that if you want a machine to recognize an image, you have to give it multiple images of this certain item, right? Yeah. I just want to ask, is it better that if you give it more images or does it like cap at a certain point?
What do you mean?
Like, let's say, for example, I want this machine to recognize what a keyboard is. Would it be better if I show it like 1,000 images of a keyboard? Or like, does it cap at that? Is that enough? Or should I keep showing it more? Like, will it actually be better?
Oh, it's always better to have more. The more it learns, the more it becomes smart. The higher the number, the better, for sure. And especially like for images, we use mostly deep learning. Like for when it comes to NLP, like natural language processing, and for images, it goes even deeper because you use millions and millions of pictures, and you need to have a very like smart model that will process all of this for you.
Thank you so much. And thank you, Levagon.
All right. So,
There is a question on the chat.
okay, let me open the chat.
How does one tackle the cold start problem in a real-world application?
Sorry, which one? How does one tackle the cold start problem in real world application? I don't understand what cold start problem is.
I can try to answer that if you
Go
want.
ahead, Sergio.
So I think it's related to I don't know, the Netflix, how Netflix work for suggesting film and all that stuff. So at the beginning it's hard to really target the client because you don't have enough client into the system. So the idea is that if you have a base of some client, you can manage to understand the new client that comes to Netflix, and then suggest him based on all the other client some of the category that he should visualize. Yeah. I don't know if that was clear.
And Abraham, yes, so Le Wagon is actually recognized as like a 3+ degree in France. And yeah, you get certified by Le Wagon and become a data scientist who is approved by many companies. Sorry about that. So for business problems, which models are mostly used? As we saw today in our graph, regressions are the most used models. You can go back to the slide and you are going to be able to see all the different ones. Let me try to open it here for you. Here we go. Here we go. I'm going to try to share. So here. So yeah, regressions, 56% are the ones that are being used everywhere. And then you get to decision trees, clustering, random forest as well. Gain nearest neighbors is next, time series because of a lot of financial markets and whatnot. And yeah, you even have here in deep learning neural networks there. And then convolutional neural networks, which is, for pictures. Mohammed, you raised your hand.
Yeah, are you able to hear me?
Yeah, I can hear you.
Awesome. So first of all, again, thank you so much for this awesome webinar, and thank you to Biagio and Charlotte for this awesome support as well. So my question is that I was working on a case. It was regarding the fraud detection. You can find it in Keras examples. So it was about the imbalanced class classification. Okay, so the problem was that when I was using Scikit Learn's .predict method, it was giving me a score, like a probability, instead of the class. Like whether giving an output of 0 or 1, it was giving me answers in float. So
did you import the right one? Which model did you import? Mohammed? Hello? Can you guys hear me?
Yeah, we can hear you. I don't know if...
I think we lost Mohammed.
Yeah.
I think we lost him, but maybe we can answer the questions in the chat, and then go back to the people who have raised their hands. You guys, it's encouraged to ask the question directly. So if you want, you can use the reactions button from below. Just raise your hand and you will be answered. But there's a question from Glenn. What is the role of machine learning in artificial intelligence, and how much is this role expected to grow in the next few years?
What is the role of machine learning in AI, and how much is the role expected? So machine learning basically is like a subset, and it is a smarter version where it becomes like automated, right? So it learns on its own. By then it becomes it just becomes a continuous automated machine, and the role expected to grow in the next few years. I mean, it's constantly growing, right? So we have now flying cars, we have autonomous driving cars, we have I don't know, we like prosthetics that you can control with your hand. It's just never ending. So I don't think it has one role. I think it has so many roles when it comes to biohacking, when it comes to everyday things, even like for receiving your Amazon things. Now it's drones are coming to you and just giving you the right package. It's a never ending world. Yeah. So there's another question we're gonna be able to target. Winston, you raised your hand. Do you wanna share?
Yeah. Hi, Kenza. Thank you so much again for this session. It was really informative and quite clear.
Thank you.
I think this question is a follow-up to what was last asked about artificial intelligence. So yes, I remember the slide where you mentioned that machine learning forms a subset within artificial intelligence. What are the other subsets that come under AI? Because I see a lot of confusion that people think of just simple decision-making programs as also artificial intelligence. Is that right? Or is that a misconception? And what are the other subsets, so to speak?
So all of this is computer science. So let's see it as a huge world. And then we have AI. That is the bigger concept. It's to create intelligent machines that can simulate human thinking and behavior, whereas machine learning is its subset. And the machine learning is the application of AI, that allows machines to learn from data without actually being programmed and explicitly. And then you have another subset of machine learning, which is deep learning. And that one is using neurons and synapses that will so deep learning is a little bit more complex to even understand today. Even for teaching it is a little more complex. It mimics the brain. So it's really like creating neurons that will take information and then understanding that information and then separating it again into other neurons and constantly doing that until receiving your output from the beginning. So deep learning is mostly used now for images and for like NLP, natural language processing. So it's not one or the other, it's all one. It's just like one takes you to the next one. Hope that makes sense.
Yeah, I understood that part. You explained that quite clearly in the beginning itself. But my question was, what are the other sets of artificial intelligence other than machine learning? So machine learning is one subset of artificial intelligence. What are other subsets that form like at the same level as machine learning within artificial intelligence? Because if you remember in the slides, you had a diagram where it was one circle inside another circle inside another circle. So what are the other machine learning level circles that are there inside artificial intelligence?
Okay, I see. Okay, so I guess there's a little more specific, but I'm guessing there's like what we call reactive machines and limited memory and ANI, which is artificial narrow intelligence, I believe. You have a bunch of other things that come into place, but the one that the graph that I showed you earlier isn't about you're talking about the AI machine and the deep learning, not the one with the data science and data analysis.
Yeah, that's right? The one. The circles, the Venn diagram essentially.
So essentially you have many other like subsets that can be happening, and it's just a question of like getting to the right, depending on what you are looking for, getting to the right model.
I think Kenza, he's referring to fields like computer vision, NLP, as subsets of artificial intelligence. I think that's the question, right?
Yeah, I guess that's more about it. I would assume that's one of the subsets that are side of machine learning.
Okay, I see. So you have NLP, you have robotics, you have machine vision, you have speech recognition, you have you have so many things that you have biohacking, you have what else? Those are the things that are coming into my mind, but it's a lot. There's a lot of things that were already created.
Yeah, all right, thanks. I just wanted to get a feel of these names, that's nice. Thanks a lot.
There are questions from the chat. Can you give us more information about PyTorch, TensorFlow, and how they can help us in machine learning?
Oh, so TensorFlow is a very, it's just another open source library made for machine learning. Just like we are using Scikit Learn, we can also use TensorFlow, and it's a little bit more advanced. So you can use their libraries, you can import their libraries, and they have also models that you can use for deep learning. It's mostly, I think, deep learning oriented than machine learning.
Okay, there's another question in the chat. How many features can a classifier train on?
As many as you want, because we have this thing that we do beforehand. You can pre-process your features, and there is a really cool preprocessor. It's called the one-hot encoding, and basically what it does is that as many classifications you have, it will give it its own column, and it's gonna encode it, and it's gonna become like almost like a binary. It's zeros and ones, and by creating like each one a column for it, so you can have as many as you want. You know, sometimes I worked with classifications of 10, sometimes I worked with classification of 50, so it really depends on your data sets.
I think let's take the question from Akil, and then we go back to the chat. Yeah.
Hello. We have a model to train and a model to test, right? How do we know that our model is ready? When we test, we test one by one, we test aleatory. How do we know that our model is properly fit?
Oh, well, it will pass. That's how you know. It will pass, like the moment you shift enter into a fitting, like it is smart enough to do what you're telling it to do. But
it might be a false positive, for example. How do we know it's correct? No, I'm thinking wrong.
Sorry?
It might be a false positive. If we train it wrong, it will be a false positive, for example.
Yeah, well, that will be showcased in your scoring, I would say. Biagio, do you have something to add? You said you raised your hand.
Oh, the scoring itself contain the amount of false positive, so it will show the score will show if you are right or wrong, really. So, yeah.
Yeah, the score is what makes it like accurate for you.
Yeah. Okay, so the scores indicates the accuracy of the data.
It depends of if it's classifier, you have 4 types of scoring. You have a precision, a recall, an F1 score, and an accuracy. And then in regressions and other ones, you have loss functions. So you can have a mean absolute square, or a mean squared error. You have so many different like metrics that you can necessarily try to use to get to the right answer. And that depends on what is the question you're asking for your data set. And that depends on what is the data set that you have.
Can I add something to that? You can simply use confusion matrix in order to find out the all grid.
You want to use a confusion matrix too?
Confusion matrix will tell you the number of true positive, false positive, true negative, and false negatives. So it will also clear up.
Yeah, that's for your accuracy and for more like classifications that you can use that for.
Okay, thank you.
Of course.
There's a question from Pulkit.
I think he just
Thank you, Marwa, and thank you, Kenza, for this informative session. Actually, I had run into a problem for like a project of mine. Like we were using LST models, TensorFlow, and while running Epoch, I was not able to get the correct accuracy for each model when it was training, the testing and training data.
Testing and training data, you weren't able to get the accuracy. Why not? I mean, it's kind of hard for me to give you a response towards that because I need to kind of know what is the data set. I need to know what are your features, what is your target. Like there are so many layers to it for me to respond, but you can connect with me on LinkedIn and we can discuss this.
Okay. Yeah, sure. Okay, thank you, Kenza. Thank you.
My pleasure.
There is a question on the chat. Do we need a degree to be a machine learning specialist, I'm assuming? What is the similarities between data science and machine learning?
Well, data science, as we saw today, it englobes like everything. You are able to also do some engineering. You are able to do the data analytics side. You can become a data analyst. You can do the work of a data analyst, and you can also do machine learning and deep learning and all these like little things. So there's a lot within the data science title, and then machine learning is really specifying yourself into one department and digging deep into the algorithms. Like now we are using libraries that are given to us. And I guess when you are a machine learning specialist, you create the algorithms. Hope that answers.
Yeah, thank you, Kenza. I'm trying to read through the questions. There are lots of questions. It's easier if you guys just raise your hand and ask the question yourself.
Yeah.
Okay, so there is a question about scoring. Does the scoring contribute to the learning of the model, or do we have to reuse the data to train the model separately?
Sorry, which one is it? Is the scoring? I'm trying to find it.
Does the scoring contribute to the learning of the model, or do we have to reuse the data to train the model separately?
Does the scoring contribute to the learning of the model, or do we have to reuse the data to train the model separately? I'm not very much understanding, but the little bit of I understand, like what I understood by this question, the scoring contributes to the learning. So the scoring does not contribute to the learning. I mean, it just gives you a score of what you have learned, right? Of what the model have learned. We have to reuse the data to train the model separately. Ikhlas, do you mind like trying to write me a little more details to your question? Or raising your hand so I can like try to understand more?
I think there are lots of questions here regarding training the data and getting the most accurate scores. And correct me if I'm wrong, Kenza, it's not as easy as it sounds to get something perfected with machine learning or with algorithms. The more information you feed it, the more you train it, the more accurate your results will be. So it will not be a one-day thing. It will take time. And in order for you to perfect it or teach it whatever you want to teach it, it will take effort. It's yes, it's a simple process, but it's a very lengthy process. Yeah, go ahead.
I'd like to add something, sorry, because today we are seeing literally like basics. We are not digging deep. It's so much more. You have optimization. You have to pre-process your data. There's so much you need to do to your data beforehand when it comes to optimization. So let me maybe share I'll try to open something quickly later. Some of the models have parameters, and each parameter you can do, for example, what we call a grid search, and you can set this parameter, I want you to try all these numbers, and this parameter try all these numbers, and through your grid search it will try to optimize it and tell you which one of the numbers is giving you the best score. So it's so much more than just like, hey, yeah, here you go, take data and do whatever you want with it. It's like you yourself need to pre-process and give it like the right numbers for it to accommodate this data and train on it.
Yes, thank you very much. Hassan, I would like to ask a question.
Yes, hello. First of all, thank you, Kenza, for the nice presentation. And my question is, it's a bit, stupid. If you had to make a system or a robot using Le Wagon, what would you make, and like what would it be, or what would the job be?
For Le Wagon or as a personal project?
up to you, you know, both. Like, tell me what you do in Logo and what you do for for you personally.
Okay. Well, were you here yesterday, by the way?
Yeah.
Okay. So yesterday I talked about the project that I did for Le Wagon. It was so if I had to continue this like to the next level to create a robotic thing, it would be prosthetic, right? So we were able to predict hand movements, 6 types of hand movements through EGG signals. And the beauty about it is that our model was able to predict a very accurate number to be able like to communicate from your brain waves directly to your prosthetic for it to react the way you want it to react. And I guess the next stage is to connect it to a prosthetic and creating like a robotic reaction towards the two, between the two.
Okay, thank you very much.
Thank you, Hassan. So Kenza, I think let's talk about machine learning and what it has achieved so far. I think it's an amazing buzzword, and we talked about the fundamentals and we talked about the basics. But what are some systems that depend on machine learning that we depend on our daily lives?
Some systems that, well, I guess what we've seen today, just recommendation engines. You go shopping and you literally are constantly getting like recommendations here. I'm sure you want this, you want that. Chatbots. Every time you have a chatbot that shows up, that's like something that comes directly to you. But to the daily, like that are important for us in the day-to-day, is that you?
Yeah, I mean it's the more relatable it is to people, I think the more exciting it is. So recommendations like I think Biagio mentioned this earlier, Netflix. It recommends the movies that I would automatically like based on things that I've watched before. And that is what machine learning does to us and how it's involved in our daily lives. So shopping online, definitely it recommends what it's the way we're wasting our money today.
Yeah, basically.
Yeah.
That's the main focus on most capitalistic business models.
Yeah.
It's like, how can they make money?
So we have a question from Noura.
Yeah. Hi, Noura.
Yes, actually, I have a question about the recommendation engine. It is similar to cookies that is track the data, or it is a different technologies?
It's a little bit different because you are, as a user, you have a profile and your information is constantly being like saved. So it's they have a data, like for example, when you like something or you put it into a list, or all of this this data is always saved into their data sets, compared to like cookies that you can delete your cookies or like block your cookies.
Okay, thank you.
Another cool thing in Marwa, I don't know if you guys use it, but I'm obsessed with it. I love TikTok. So TikTok is one of the smartest like recommendation engines that I've ever seen. It's so accurate when it comes to understanding your behavior, your likings, your like trends and whatnot. Then all of the social medias in general are very smart and are using machine learning constantly. Let me open the chat.
Yeah, I mean, everyone loves TikTok. It's fun and it's clever in many ways, and yeah, you're right. It understands us in more ways than we'd like to admit. Okay, there's a question in the chat. I think it's cool to know. Data science projects that you would recommend for beginners for further learnings. What could they work on to increase their learning experience?
Let me open this for you. Okay, share. So I would like you to go to Kaggle. Kaggle really has so much information for you to play around with. You can just look into the data sets You can try to understand like anything, by the way. Like, it's not about the data set that you have, it's about what you want to do with it. Sometimes you can make it as simple as like a linear regression like we've done today, or you can push it to the next level, right? So it's really depends on what is it that interests you, what is it that doesn't, and pick any of these. What's amazing about these is that, for example, let's say I'm going to open the music genre classification. Okay, this data set already has people who code in it. Oh, this one doesn't. Yeah, this one is pretty much empty. So let's go back. Go to here. For example, New York here. See, you have code. You have 578 people who sent their code in it. So just to also have an idea of where to start, you can go check out what people did. You can understand like the patterns that they went through, or what is it that they imported, what is it that what kind of visualization they use, and from there you can get to your own conclusion. Okay.
Thank you, Kenza, for that. We'll take the question from Leif, and then I think our time is almost up. We'll see if we have time for one more. Leif, go ahead, ask your question.
Okay, thank you. My ask is for you, Miss. If we have another course, and what should we do in another week?
For me, so you will receive the weekly schedule on your emails, and with the topics and links and everything. If it's a physical session and you'd like to attend physically, you need a negative PCR result. If it's a virtual, then we will send you the links. However, if you're unable to attend physically, you can still watch us live on YouTube. Hannah, my colleague, now will be sending you the link to all our social media platforms, where all our information is always up to date. So anything, any changes or anything, it's always there on our social media platforms. Thank you, Faith. Sruti.
Okay, thank you. Can I another question?
Yeah, sure.
Yes, the link for another course for next week. It's for all of them, or for people and people know?
Can you repeat the question? I didn't understand.
I say if the course in the next week, it's for everyone, or for people, for person.
Okay, I got it. Okay, so we usually send the links for everyone. However, there are some sessions that are exclusive for a certain number of people who have registered, and we select based on certain criteria, but most of our sessions are open to anyone. If you want your certificate in those sessions, you have to be registered through the website. So you can enter the Zoom link, and if you're not registered, unfortunately, we will be unable to send you the certificate by the end of the month. So some entities like Lewagen are kind enough to share their own certification for such sessions, but other sessions, we are the ones who are sending these certificates by the end of the camp. Okay, let's take
Thank you very much.
You're welcome. Let's take a question from Sruti.
Good afternoon, ma'am. Thank you for this session. I just wanted to ask Insa something. We know that like most of the e-commerce web applications which are there are developed using either Magento or any other PHP based applications. They already have recommendations in that. So the recommendation that we're speaking over here, can we integrate that into those kind of platforms also, like which are already built in, and can we have a plugin like that? Because I'm confused with the two. You had mentioned regarding that for Netflix or Prime and all that, Amazon Prime, they're all using this AI based machine learning recommendations is what you had mentioned, right?
Yes. Yeah, definitely. I believe that you can have built-in plugins for your personal recommendation engines, but at the end of the day, it's each company has its own regulations, so it depends of the solution that you're using. But I would say yes, you can definitely like have a plugin.
That is, after I learn this, I can build another module or something which can be integrated into already existing systems, is it?
Yes, definitely. So just the first part is to ask the owners, like whichever solution you are using, ask them what are the regulations that they have. Do they allow it? Do they not? And once they do, you can definitely go to the next phase into creating it. And also,
thank you.
Definitely.
Yeah.
No, that's it. I thought I would.
Thank you, ma'am. Thank you.
Okay, I think we have time for one more question only. Mona, you can go ahead and ask your question.
Hey.
Hi.
Hey. Hi. Thank you for this amazing session. I have a question for Kenza. I'm fairly new to coding and to data science in general, and I just want to know how much of it is based on mathematics. If not, it's the essential part of it. And do like that data scientists continue to improve their mathematical skills? Like, I know it could help on like solving problems in a creative way, because I had like one or two programming courses, and I know at sometimes, because due to my like simple knowledge in math or the classes that I had, I would like break down a code in a very simple like language, because knowing that there is like a possible very smart way in solving it and briefly. So do you like continue learning and improving your mathematical skills?
Yeah, definitely. I think it's very important to understand at least the core concepts, right? Like understanding how regressions work, how gradient descent work, because all of these are like the core meaning of all these models. To understand like what is happening in the background. It's not just like, hey, I'm gonna plug this and see what this does. You need to kind of have a general, more of a depth understanding of mathematics. That does not mean that you can't do it. It just means that you need to refresh your memory every now and then, and or look into the model and what is their algorithm and what is it based on and why it does what it does.
Yeah, I see. Apart from the like built-in features and functions, do you ever like make your own functions?
Yeah, of course.
That would help you?
Yeah, well, not as a model, but like you use a lot of functions in the pre-processing, and like how do you use those the predictions? You have like you're constantly doing your own coding as well.
Oh, okay. Thank you so much for answering the question.